Okay, here's a quick example and some explanation of how the a11n IO cerberus application works. So it's just very high level architecture and usage of the personas and actors in the system. So we've got the a11n or cerberus nicknamed application. The developer persona, which is me, define the capabilities in the system, very similar to how AWS defines their authorization capabilities in terms of resource types, actions and policies, which groups those actions. So when a SaaS company looking to develop a product has their admin persona register with me, a account is created on my side. That same, or the admin persona, whoever has access, will add users and roles to the system. Eventually this will be done with plugins. Right now it's just manual. The developer persona will define the capabilities of the product that they're looking to create. So again, this is very exact same resource types, policies and actions that I work with in my system. So my system uses the same authorization under the covers as everyone else uses. When they create a product, the developers will instrument this product using my front-end and back-end libraries. So the idea is that for most popular languages there will be a library available which we maintain, and the idea is that the front-end libraries are able to show and hide content based on permissions for the user, and the back-end libraries will do the access checks based on the user permissions. So before any action is executed, the first does an access check. So there's two ways to do it. One is with REST APIs, and the other is with WebSockets. So normally the front end works with WebSockets. So when a customer of theirs registers for a product or registers an account on their product, an account is also created on my side underneath their account. Their admin will again add their users and roles to this account that they've just created. Their user persona will now use this product by adding and querying resources, and those are mirrored again on my side. When they use the product based on their permissions assigned to them, it will make access calls which will either deny or approve access to those resources. So that's in a nutshell how it works. So we'll go through a quick example. I've developed a little project management example application. So back end is in Golang, front end is in React. This is a really simple example of a project management application with sprints and stories. So we've got two branches, one vanilla branch that I'm on right now, which doesn't contain any permissions or no access checks at all. And then we've got a permission branch which is instrumented with the libraries that will do the permission checks. So let's just run this and we'll see how that works. So we'll start it up on the back end, and on the front end also start this. Alright, so here's the little Acme Project Manager app. We'll start with registering an admin user. This is all just kind of dumbed down authentication for just to highlight the usage of more my product and not a fully fledged application by itself. So now we can log in. Here's the usage of the application, so anyone can now create a project. So we'll call it project 1. And we'll create the sprint here, so it's the first sprint, and we'll create some stories in the sprint. So we'll create framework, create another story, create login, whatever, some stories. And you can do some simple stuff like estimate the story, and we'll give that 3 points, and that's still in to-do status. So, and we can, what we can do now is invite some users or create some users. So again, this is the application that the SaaS company is writing, and this is now an admin of their customers who's logged in, and he's gonna create some customer users here. So we'll start off just creating a PM customer, project manager, dummy customer. We'll do a developer, and we can do a tester as well. Alright, so here's all the users. Now, that's really simple and everything, but the fun starts with permissions. So what this admin will do is he will log into my Cerberus dashboard. So this is just running on localhost connected to my test environment on AWS. I've added myself as an admin here, so I've already registered. This is just my login now. The first thing that we'll do, well, here you can see some settings. I've also added another user here, so auditor. So you can see, so these types of widgets will be available for everyone using the system, also other software, which we'll see in a second, using the client libraries. And what's nice is you can view the user role relationship from both sides, so I can see which roles I'm in, and also if I look at that role I can see the users that's in that role, and can see the permissions for this resource. So this is a top level resource, this is the account, and I can manage the account, and I've created an auditor role that can read the account, and you can pretty much do anything you want here. So these are all the other policies in the system, and you can assign users to these policies. So back here, what we want to do is we want to create, I've already created the app, but just let me remove this so we can start from scratch. Okay, so we'll create a new app and call it Acme project. And we'll create a new API key, which we'll need in a second. So to use that API key, I will now switch to the permission branch. So this has been predefined with a bunch of stuff. One is an environment file where I need to specify an API key, so I'm going to use this. And the secret. And the other thing you see here is migrations. So this is using the lingo of the Cerberus app, I've got three things. I've got resource types, actions and policies, which defines the capabilities of the software. So for this example app, there's a tree structure for resource types. So you've got a top level account, you've got a project underneath an account, and a sprint underneath a project, and a story underneath a sprint. So these are your resource type tree structure. And for all those resource types you can define actions. So an account has all these actions to it. And then you define policies for those actions. So for a manage account, this is the description, and you can define a manage account by these actions on these resources types. So that's how you do it in the DSL, and you can, what they can do, customers, is the SaaS customers that uses my app can then integrate these migrations in their software development lifecycle. So when they just get started, they might only create one level deep of resource type with a couple of actions, roll it out to the users, and as they continue to progress and add more features, they can add more migration files here as they go on and release them. So that's a nice automated way of doing it. The other way to do it would be to use the dashboard, but that's obviously not in concert with their releases. Alright, so let's see, once we start this up, okay, let's just shut down the other one. I'm going to rebuild this to make sure. So looking at the back end, just want to show usage of the client library. So here we're importing the Go client library and also a migration library for Cerberus specifically, and this allows using the API key and secret that's been defined, that it's pulling from the environment, allows you to do migration, and it also allows you to run specific commands. So here I've got, this can be extracted into a script, but this is for migrating existing software. So it's just reading all the accounts in the thing and then using my client to create those types. So I've got some functions here. So accounting, super role command, user command, assign role command, create resource, and create a permission for a role. And there's many more functions in the library that's available, but this is to migrate existing data. And then once you're migrated and everything, you will use the client library. So every time, so in this service, it's a project service. This is the function that creates the project, for example, or a sprint or a story. So their developers will, every time they create a project locally in the system, they will also mirror it on my side. And in this case, it's protected with a transaction. So if one of these fails, everything rolls back. And the same is in the front end as well. So I've got a React library that I can use. So here, for example, in projects, I've got things like access guard that checks the resource ID with a specific action, saying, well, if the user logged in has this permission, saying it can, via a policy that's assigned to that user role that the user belongs to, can he create a project on this account? Yes or no? If he can, then this button is shown, or this widget is shown. So that's how the front end works with this. And there's also more complete widgets. So this is just a widget, that's the only thing they have to do, and then they will see this entire widget here that shows them the permissions and users and roles and everything. So let's fire this up. I've already set up the the environment file. Yes. So we can fire this up. It will now use the API key to connect with my server, and it will do the migration automatically. Here's the migration that's done. Also the local resources in the application is also being migrated. So let's just see how that looks. So here on the dashboard now again of Cerberus, we can see that there's one successful migration. I can see, given the Cerberus migrations of the resource types, the capabilities, that's all been successfully migrated. So for a story, there's all these actions that's defined in the resource type tree. And the same for a sprint and a project and an account, all different actions. And then the policies linked to those actions, so you can, the top level policy here that can do everything, manage account. You can see here in the tree that it's allowed everything. And on the flip side, something that can only read a story, nothing here, but only on story. There's a couple of read actions that allow it. So you can obviously play with this. You can add more actions. You can allow more actions on this policy, but that will cause drift with your local, with your own migrations. So it's better to use the migrations than to play with the dashboard. And here's just some data for the account. You can see the users and roles and resources, everything, the IDs for them. Alright, so now that we've got the back end up, we'll start the front end as well. Okay, so this is now the permissioned one, and we'll log in with the admin user. So the admin user can see and do everything in the account. So you can still see the projects and everything, but now there's more settings. So that one little, let's see, this one here, this one little account permissions here. So there's roles, users, and account permissions. These are all automatically given as part of the client library stack. So you can see the roles in the system. We've created admin, dev, there's no users. Well, these are the users, these are the roles. I haven't defined any new roles. There's one automatic role that's created whenever someone logs in for the first time, and that's the account administrator role. But that's again defined by the developers of this application, the SaaS application. So what we can do is we can create some new roles. So whenever a role is not selected, we can create one. So let's create a project manager role, and we'll also create a developer role and a tester role. So I've got these three roles. I'll assign dev to the developer, I'll assign the PM to the project manager, and I'll assign tester. So those are my roles. Now I need to define the permissions for them. So the account administrator can manage, can do everything. I'll assign one to the, oh wait, needs to be refreshed. Here we go. So for the project manager, I'll allow him everything as well. for the developer role, I'll say that the developers can manage a project, but they cannot create projects, they can only manage them, and everything underneath the project as well. So here's a little description: manage everything in the project, including sprints and stories. And for the tester, let's say that the tester can read a project. They cannot change anything, they can only read projects. So let's see how this works. So I'm logging out and I'm logging in as the PM. So here I can create a project and I can see existing projects. When I go to settings, I can, since I'm also the account administrator, I can do pretty much everything that the administrator can do. Here I can still do everything on a project. I can do some estimation here. We'll log in as a developer. Now when I go to settings, the developer has no access to any of these things because he's not an account administrator. And he cannot create a project, but he can see a project. He can manage a project. So here we can create new sprints, we can work on this sprint, and we can pretty much do anything underneath a project level. I can assign this to myself. I can assign this to someone else, all these kind of things that we can do. And again here we can see some permissions, and I'll show an example of what this means. So this shared custody here basically means that this sprint inherits everything from the upper permissions, but I can cut it off and I can create my own. If I want to make it more private, I can select to make it more private here. But we'll see how that works in a second. So let's just look at the tester. So we'll log in with the tester. Again, settings, tester doesn't have any access there. He cannot create a sprint, but he can look at a sprint. He cannot create stories, but he can look at a story. Cannot change anything here because he doesn't have any access. And again, because he's only got read access, he cannot change anything in the permissions. So let's log out the tester, and I want to show how you create or how you manage the permissions for any of the resources. So we'll look at this resource, the sprint for this permission. So let's say I, as a developer, I want to add only myself to manage the sprint. So I add myself, so I can manage the sprint, and now I can cut it off. So no one else can see this permission anymore, or see this sprint anymore, besides me. So if I log out, and I log in as the tester, I go back here, look at the project, cannot click on it anymore. I don't have access to it now. So what I can do as a developer, one of two things. I can either invite a tester. So let's see. So for the sprint, go back to permissions, select the user. I can say all testers can read the sprint. So if I log back in as the tester, now I can go into the sprint and I can read everything in it. But I cannot change anything. That's in a nutshell how it works. The idea is that SaaS developers get out of the box a easy to use kind of opinionated way to deal with permissions. They get the UI elements for free, they get client libraries for free that they can use, and everything that goes around with it, and they even a language that they can use in migrations. Eventually we can look at maybe even doing this with AI, that AI inspects their code base and comes up with the structure, so it make it even easier for them. But yeah, that's the basics. It's very functional at the moment, not pretty, but very functional. Alright, that's it. Thank you.